Hello students, in this video we are going to discuss about second problem from exercise 1.1, 1.5. So before going to solve these problems from second one, first we need to know a definition about common logarithms. A logarithm whose base is 10 are called as common logarithms. Often these logarithms are found without any base. So whenever there is no number in the base, we have to assume that there is 10, and those are called common logarithms. So let us solve the first problem. Log 2 plus log 5. Since there is a plus between these two arguments, we can multiply them, then this becomes 2 times 5. As I told you earlier, we can write 10 as a base here. Then this becomes log 2 times 5 is equal to 10 and to the base 10. So whenever the logarithm to the same base is found, its value will become 1. Similarly, we will solve one more problem, that log 16 to the base 2 minus log 2 to the base 2. So we need to simplify this one and find those values. Since there is a negative symbol between two logs, we can divide these two arguments, and I can write it as logarithm of 16 by 2 to the same base, because here bases are same. Then this will be equal to log 8 base 2, and further I can write this 8 as 2 power 3 to the base 2. So here we have power for this argument, and this power comes here and becomes 3 times log 2 base 2. So here the argument and base are equal, then the logarithmic value will become 1. So 3 times 1 is 3. This is how we can solve this problem. And we see one more problem, that 3 times logarithm 4 to the base 64. This we can easily solve, as we have one of the property that this integer can be written as power for the argument, and this is base 64. And now I can write it as log 4 cube is 64 and the base is also 64. The entire logarithmic value will become 1. And one more problem we are going to see in the same section, that 2 log 3 minus 3 log 2. So we need to simplify this one and make it as a single logarithm. If possible, we will find its value. So just like the previous problem, we can write this 2 as power to the argument, and this becomes 3 square minus log 2 cube. And since we have negative symbol between logarithms, we have to divide the arguments. First we will write value of 3 square is 9 and this is 8, and now I write it as 9 divided by 8. This is the final value. And one more we are going to see, that is log 10 plus 3 times, no, it is 2 times log 3 minus log 2. Here we have 3 individual logarithms, connected by plus and minus. We will simplify them. Log 10 plus, since we have 2 here, that becomes power for the argument, that is 3 square minus log 2. So this is log 10 plus the value of 3 square is 9 minus log 2. So all are individuals. Since we have plus here, we need to multiply these two arguments. Then this becomes logarithm of 10 into 9 minus log 2. So logarithm of 10 times 9 is 90 minus logarithm of 2. So in the first logarithm, the argument is 10, and the second one it is 2, and between we have negative symbol. So this will be log 90 divided by 2. Then 90 divided by 2 gives 45, and this will be the final value. In this way, we have synthesized, as we discussed in the introduction of logarithms, about the definition of a logarithm. Simply we write logarithm of n to the base a, where n is greater than 0, a is greater than 0, and a is not equal to 1. We call this n as argument and this a as base. So I hope you understand this video, and if you have any doubts, you can comment them in the box below, and thanks for watching.